Fasten your seatbelts. You're about to embark on a troubleshooting journey. Travel inside a Sony CCD F33 camcorder and explore the different avenues of successful 8mm troubleshooting. We'll begin our voyage in Tape 1 with an exploration of the VTR section and travel through various troubleshooting techniques for the camera section in Tape 2. These tapes will help you identify problems quickly so you can reach your repair destination in record time. To begin our troubleshooting journey, let's first go over the power-up sequence, which tells us a lot about the functioning parts of the VTR. With the power switch in the off position, apply power to the camcorder. The viewfinder should operate for about 1 second. This check is only valid if the viewfinder has not been damaged. Therefore, look for other power-up indications as well. For example, with a monitor connected to the camcorder, you should observe a momentary white raster on the screen. If the camcorder has an LCD display, check if it is functioning as well. If you observe these power-up indications during initialization, you can be sure that the power supply is functioning and that the servo system control has been reset. If initialization does not occur, remove the lithium battery if one is present. This ensures that all the micros within the camcorder are reset, including the key matrix and date and time control ICs. Now, to start the initialization process again, remove the main power. Wait a second or two and then reapply it. If resetting the micros in this manner does not solve the problem, then check the power supply stage. It is covered in Tape 2 of this program. Remember, reinstall the lithium battery after repairs. The next stop after checking the power-up sequence is to see if a tape loads. Press the eject button to open the cassette compartment. If it opens, then insert a cassette. Once the cassette is inserted, place the power switch to the VTR position. The drum motor should be heard spinning, and the tape should be seen threading. Once the tape is fully threaded, the unit should pause. The servo system control then waits for an input command, such as play, rewind, or fast forward. If the cassette does not load or thread when inserted, disassemble the unit to check the mechanical operation of the VTR. Remove the tape, the cassette lid, and the camcorder's right cabinet. Most of the problems you are likely to encounter with the camcorder will be of a mechanical nature rather than a failure with the electrical stages. If a tape does not load or unload, use a mode selector box to test the mechanical operation of the VTR. The mode box with the number 3 overlay enables you to manually load the mechanism and display the transport position. If no mode box is available, a DC power supply can be substituted. However, the mode box operates at 2 speeds, slow or normal, and it also verifies the correct operation of the mode control switch. To connect the mode box to the loading motor, the 2 alligator clips can be used. For some units, the mode box adapter board can also be used to connect it to the loading motor, as well as provide information about transport position. Because our unit is only partially disassembled, the alligator clips are used. Connect them to the loading motor. Once connected, flip the speed switch to the normal position. You can drive the motor forward and back by pressing the upper load and unload buttons. Observe the transport for sluggish operation, binding, broken parts, and misoperation. You can also check that the mechanism is in proper alignment to the mode selector switch. However, to access the mode switch connections, you must first remove the camcorder's upper cabinet assembly, the left cabinet, and then separate the VTR and camera sections. With the unit separated, connect the mode box to the adapter board. This time, the 2-pin connector will be used to power the loading motor. Disconnect the mode switch and connect it to the board as well. With the mode box connected, you can check mechanical switch operation by pressing the lower direction buttons. Observe the mechanism and compare its position to the lights being displayed on the box. The red LEDs indicate mechanical position, and the green LEDs light between positions. These lights are turned on by the mode selector switch on the bottom of the transport. The mode box lights should also be displayed in a certain order. In the U mechanism, first the eject indication lights, then 1A, unload, 1B, stop, and finally 1C. A quicker way to confirm proper operation of the mechanism without extensive disassembly is to use the RM95 remote control. It is a great tool for diagnosing various camcorder problems for both the VTR and camera. The RM95 will be discussed in greater detail later in the tape. For now, we will show you how to access data about transport position. Before connecting the RM95 to the camcorder, unsolder one loading motor wire. Then connect the alligator clips from the mode box. This allows you to control the loading motor from the mode box. Apply power to the main battery terminals using a DC power supply. Then, plug the RM95 into the remote jack on the camcorder and move the power switch to the VTR position. Slide the switch on the top of the RM95 to the adjust position. You will see a hyphen displayed which indicates that you are in the service mode. Press the fast forward button until a 4 appears on the left side of the display. It indicates transport position. In the U mechanism, the numbers change in order from 00 to 05 on the RM95 during loading. Again, compare the number displayed with the mechanism position. If they do not agree, disassemble the unit and check the transport gears for damage and then align them to the service manual or 8mm mechanism's videotape. If the VTR position and the mode switch are in alignment, the loading problem is probably electrical. Check the Syscon sensors. There are 8 electrical sensors and switches that are constantly monitored by the servo system control CPU after the tape is detected. These sensors are DO, tape end, tape top, supply reel, take-up reel, drum PG, capstan FG, and the mechanism mode switch. All of these sensors and switches inform the servo system control CPU when a problem occurs with the tape or the mechanics. If a problem is detected, the unit either ceases that function or enters the emergency mode. Once in the emergency mode, the CPU will not accept any commands or perform any functions until it is reset. What happens when the servo system control CPU loads a tape into the VTR? To start the loading process, the servo system control CPU must first receive an input from the cassette down switch. In this unit, the switch is mechanically closed by the cassette loaded in the compartment. Once the cassette down switch closes, the servo system control CPU uses the tape end sensor, the tape LED, and on the other side, the tape top sensor to see if there is a cassette in the unit. If the tape blocks either sensor, there is a cassette present. If the tape is positioned in the clear leader area at the beginning of the tape top sensor detects light. When inserted in the mechanism, the servo system control CPU first loads and threads the tape. It then immediately fast-forwards the tape to the opaque area so that the sensor is blocked. If clear leader is exposed at the end of the tape, light passes to the tape end sensor. When inserted into the mechanism, the tape loads and threads. You will not be able to make the unit perform any VTR function. You must first rewind the tape to the opaque area. Now the VTR functions will operate. If the tape fails to load, you should verify proper operation of the tape LED and both tape sensors. One way to check the operation of the tape LED is to view it through another camcorder. With the camcorder powered up and no tape present, close the cassette compartment. If you can see the tape LED pulsating, it is functioning properly. Another way to ensure that the LED is operating correctly is to scope the tape LED at its cathode end. The waveform normally present if the LED is functioning is a 23 millisecond square wave signal pulse. To verify proper operation of either the tape top or tape end sensor, check the appropriate servo system control CPU input port for key scan pulses. Again, these pulses only appear with no tape when the cassette compartment is closed. If the tape sensors are blocked, the servo system control CPU sends a drum on signal, a direction signal, and a D2A signal to the drum driver IC to spin the drum. Once in the spin-up mode, the servo system control CPU looks for the drum's PG pulses to be present. If the PG pulses are not detected within 4 seconds of the drum-on signal, the loading process is immediately aborted and the servo system control CPU enters the emergency shutdown mode. At this point, the tape can only be ejected and the loading process can then be reattempted. In order to observe tape slack, block both sensors without a cassette present. Before the tape is threaded, the system control CPU rotates the reel table using the capstan motor in order to remove any tape slack. To do this, the system control CPU sends a cap-on signal, a direction signal, and a D2A signal to the capstan driver IC to spin the capstan motor. If the capstan motor fails to turn, the tape does thread after about 6 seconds of the cap-on signal. The emergency mode will not be triggered, however, until a VTR function button is pressed. In these modes, the take-up and supply reel tables should turn. When they do not, the emergency mode is triggered. The RM95 remote control can be used to quickly identify the cause of an emergency shutdown without actually opening the unit. Connect the RM95 to the remote control jack on the camcorder and place it in the service mode. Once in the service position, the Servo System Control CPU communicates emergency data to the RM95, which is displayed in hex code. In addition to emergency data, the RM95 can also be used to measure battery voltage potential, identify transport position, and align camera circuits. On current camcorders, it can also be used to shift the ATF servo for tape path alignment. The LCD display indicates the service mode by the hyphen symbol. It also shows the page, data, and address currently being accessed by the RM95. The page digit shows the service mode. Use the fast forward button to cycle through the possible service categories. The service manual for the CCD F33 camcorder tells you which page, data, and address you should access for troubleshooting. Category 1 indicates the battery's voltage potential in a coded format. Category 2 indicates the last emergency to have occurred, which is stored in the Syscon IC. Category 3 indicates the present emergency condition, but it is not retained in memory. Category 4 shows the position of the mechanism. To illustrate how to use these codes in troubleshooting, load a tape into the camcorder while stopping the upper drum. This causes system control to enter the emergency mode within 5 seconds, as shown by the up arrow on the RM95. Press the fast forward button until Category 3 is displayed, which is the present emergency condition. Note the emergency data. To interpret this data, simply find the 0105 indication in the present emergency error indication chart in the service manual. In this case, the 0105 means that a drum PG error occurred when the drum started spinning. The number 1 means that the emergency condition occurred during the tape's threading process, as indicated at the bottom of the chart. The RM95 remote control is a very useful tool for diagnosing emergency shutdown conditions. For a complete listing of other service-related codes, refer to the service manual of the model you are repairing. Although most problems appear during loading, some problems appear only in playback. Common playback problems include a clogged head or a bad head. Play back a known good reference tape and observe the picture on the screen. If the picture is noisy, eject the tape from the unit. Start troubleshooting by cleaning the heads with an approved video head cleaner. Pour the cleaner onto a chamois cloth. Then, place the cloth against the head. While turning the drum with one hand, apply just enough pressure to feel the head pass under the cloth. To finalize cleaning, play a Sony cleaning tape in the unit for 15 seconds. Cleaning the heads first should solve most clogged head conditions. However, if the picture is still noisy or if the problem is extreme, it is possible that the heads are bad or that there is a problem in the RF stage. If the noise only appears in one or more bands, it is likely that the VTR's tape path alignment is off. Before performing a tape path alignment, you should first clean the mechanical sections of the transport. These include the tape guides, the capstan shaft, the video head drum, and the pinch roller. You should also check the transport's back tension, supply reel tension, take-up reel tension, and readjust if necessary. These procedures are outlined in the 8mm Video Mechanical Adjustment Manual No. 3 for the U mechanism. In order to check tape path alignment or signal trace the RF video amplifier, you must scope the RF video signal. Insert a 5-pin male connector with extended leads into this connector. With power applied to the unit, load a videotape with a known good signal into the mechanism and press play. Connect channel 1 of the scope to the 30 Hz RF switching pulse signal, which is used to sync the scope. Connect channel 2 to the RF video signal, which is output from the RF amplifier, and also connect ground. On the scope, you can now observe the playback RF signal output from video head 1 and from video head 2. In this case, the video head 1 playback RF signal is observed during the RF switching pulse high period. The video head 2 playback RF signal occurs during the RF switching pulse low period. Use a dental mirror to look for tape float or curl at the top and bottom edges of every tape guide. If the tape guide forces the tape up or down, curling will result, which actually wrinkles the tape. On the other hand, if the guides do not exert enough pressure, floating results, which causes the tape to ride uncontrolled across the heads. If tape float or curl is apparent, eject the tape and load an RF tracking alignment tape. Then loosen the number 3 and number 6 tape guide post lockdown screws enough to allow you to turn the tape guides. Now press play. Note that when using the tracking alignment tape, only the video head 2 RF signal is seen on the scope. In order to adjust tape path, you must first electrically force the automatic track finding servo to mistrack the tape slightly. This will aid in the proper alignment of the tape. To do this on this model, insert a 3-pin male connector with extended leads shorted together into CN508. When connected, notice that the RF video waveform is reduced in amplitude. Now adjust the number 3 tape guide for a flat RF envelope at the entrance side of the RF envelope. Then adjust the number 6 tape guide for a flat RF envelope at the exit side of the RF envelope. When complete, remove the RF tracking alignment tape. Then load the P6-120 to check the tape guides again. Press play. Again, inspect the tape guides with a dental mirror for tape float or curl. If no float or curl is observed, press stop. Tighten the number 3 and number 6 tape guide post lockdown screws. Press play and then rewind to execute the review mode. Now inspect tape guide number 2 with the dental mirror for tape curl at the lower flange of the tape guide. If the tape curls, adjust it until straightened. Also, Check that the tape is not bent in the area between tape guide 6 and the capstan post. If it is, eject the tape. Then turn the height adjusting screw of the number 7 tape guide clockwise or counterclockwise. Now load a P6 120 tape. Press play and then rewind again. Check that the tape is not bent between tape guide 6 and the capstan post. Repeat this process until the tape is straightened. In addition to checking for tape curl while in review, also confirm that the RF envelope peaks show a constant and even pitch for 5 seconds or more. The RF envelope should also return to a flat condition within 2 seconds of releasing the rewind button. If the pitch is not constant or the RF envelope does not return to a flat condition, readjust the tape path and recheck the adjustment of tape guide number 7. Next, press fast forward while in play to execute the Q mode. Confirm that the RF envelope peaks still maintain a constant pitch for 5 seconds or more. The RF envelope should also return to a flat condition within 2 seconds of releasing fast forward. As a final check, remove the 3-pin connector from CN508 on the VK1 board. The RF envelope should return to its normal amplitude and it should also be flat. Finally, recheck the RF envelope signal in the Q and review mode. If the peaks maintain a constant pitch and the RF envelope returns to its normal amplitude within 2 seconds of releasing Q or review, tape path has been properly adjusted. The first half of our journey is now complete. We have explored various troubleshooting techniques for the VTR section of a Sony camcorder. We examined the power-up sequence, how a tape is loaded into the transport, different mechanical checks using the mode selector box, and RM95 operation. We also learned how to troubleshoot the Syscon sensors and several playback conditions, ending with a detailed look at tape path alignment. You are now on the road to successful 8mm camcorder VTR troubleshooting. Camera troubleshooting is just ahead on Tape 2.